Okay guys, so this section is going to be over solving logarithmic equations. So we're going to actually be solving for x in this using our properties of logs. Okay, so the first one, 7 to the 2 power is equal to x. So I'm going to convert everything to exponential to solve for it. 7 squared is 49. So that's my answer, 49. Now, when solving these problems, you've got to make sure that your argument always comes out to be positive. So if I was to plug in a 49, it comes out to be positive. Next one, x to the 3/2 power is equal to 27. Okay? So remember what we said earlier when we were solving rational exponent equations? We would rewrite this as square root of x cubed is equal to 27. And if this exponent was positive, if it was a even number, we'd have to do plus or minus. So it's not even, so we don't have to do plus or minus. So to get rid of the 3/2 power, I'll raise both sides to the 2/3 power. So I get x is equal to cube root of 27 is 3, 3 squared is 9. Okay, the next one, x to the 0 power is equal to 2. Now, this is not a true statement because anything to the 0 power is equal to 1. So this would be no solution. And it's okay to have no solution. That happens. Okay, the next one, 2 to the x power is equal to 64. Okay, so I know that 2 to the 5th power is going to be 32, so 2 to the 6th power is going to be 64. So going back to what I told you, you'll need to make sure you memorize your first 1 through 25 of your squareds, your first few cubes, your first 2 fourths, first few fifths, sixths. It's just getting used to doing this stuff. So next one, 2 to the 4th is equal to x minus 9. So 2 to the 4th power is 16. So that means x comes out to be equal to 25. Now I'm going to take my answer, I'm going to plug it into the argument. 25 minus 9 gives me a 16. So the argument is positive. Okay, the next one, we're going to have to isolate the log first. Just like we isolate exponents first, just like we isolate roots first, we have to isolate the log first. So I'm going to subtract 15 to the other side. So I get 2 log 2 of x is equal to 10. Now, I can do this 2 different ways. I can move this 2 up here to that, but what I suggest you do is to divide it over to the other side. So I get log 2 of x is equal to 5. And then we have something simple to do. 2 to the 5th power is equal to x. 2 to the 5th power is 32. That's my answer. Okay. Now, when we're doing these types of questions that have multiple logs in it, we want to get all the logs on one side and all the numbers on the other. So I'm going to move the 2 to the other side. I'm going to move this log over here. It's like that. Okay, so when we add logs, we're going to combine and multiply. Like that. And so we have 1 log. When we have 1 log, we're going to do 8 to the 2 power. So 8 squared is going to be 64 is equal to 4x. So x comes out to be equal to 16. Okay? If I plug it in, all my arguments would be positive. Okay? Okay, on to the back page. Sorry, my spacing was bad on this one. So just like the previous problem, we're going to get all our logs on one side. So 2 log 4, 8 minus 2 log 4x is equal to 2. Now, all of these terms are divisible by 2, so that will help you out. So I'm going to cancel a 2 from every term, and I'm going to make that a 1. Okay? When there's subtraction, we're going to treat it as division when we combine it. Okay? And I'm going to say 4 to the 1 power is equal to 8 over x. Okay, and I'm going to cross multiply. So 4 to the 1 powers is 4. X is equal to 8. So x is equal to 2. Now, if I plug in to my arguments, they all come out to be positive. Okay, now these are super easy. When you have logs on both sides and there's nothing else involved, no numbers involved, you just set the arguments equal to each other, okay, to solve. So we're going to do 3x plus 5 is equal to 8x minus 12. So I'm going to do 17 is equal to 5x. So x comes out to be 17 over 5. Okay, so we get all our x terms on one side and all our numbers on the other to solve for that. Plugging in 17 over 5, everything comes out to be positive, so we should be good to go. This one, so we have logs on both sides. Now, what you might be tempted to do in this case is divide this 3 to this 27. You cannot do that. You can't manipulate an argument, okay? So this 27 would be that argument. But what you can do is you can take this 3 and bring it up to the exponent. So I have this going on, and I have logs on both sides, so I can set this argument equal to this argument. So x cubed is equal to 27, and to get rid of a cubed, you cube root both sides. So cube root of 27 is 3. Okay? And we're doing this without a calculator, so you need to make sure you know how to do this without a calculator. Next one. We have a lot of logs going on here. Can't simplify this. I can take this 2 and bring it up here. So it's log 2 of 3 squared, which is 9. And when there's addition, we're going to combine by multiplication. So log 2x is equal to log 2 of 45, like that. Now, when I have logs on both sides, I set the arguments equal to each other. So I get x is equal to 45. If I plug in, my arguments are all come out to be positive. Okay, next one. On the left-hand side, we're going to have division because there's a subtraction sign right here. We're going to take this 1/2 and this 2 and bring it up like that. So I get log 2 of 2x minus 1 all over x plus 5 is equal to, let's see, 36 to the 1/2 power is 6. And 2 squared is 4. So this would be log 2 of 3/2. 6 divided by 4 is 3/2. Okay? Now, when we have logs on both sides of the equations, we set these equal to each other. So I get 2x minus 1 over x plus 5 is equal to 3/2. We're going to cross multiply and solve. So we're going to get 4x minus 2 is equal to 3x plus 15. Get all our x terms on one side, so I get x is equal to 17. If I plug that 17 in, all my arguments come out to be positive, so we're good to go. Okay, last couple of problems. Log 4 x plus 3, log 4 of 2 minus x is equal to 1. So there's multiplication going on here because there's a plus. Okay, so we're going to say 4 to the 1 power is equal to x plus 3 times 2 minus x. Okay, so we're going to FOIL this out. 2 times x is 2x. Your outer terms is minus x squared. Your inner terms is plus 6. And your last terms is minus 3x. Okay, remember when we do quadratics, we're going to probably factor. That's probably going to be our first strategy to do. And we need to make sure we set it equal to 0. So I'm going to move everything to the other side. And I'm going to make sure I have a positive x squared term. So move that over. 2x minus 3x is negative x. When I move it to the other side, I get plus x. And then 4 minus 6 is a negative 2. So when I factor this is x plus 2 and x minus 1. So I get x is equal to a negative 2. I get x is equal to 1. Now, we're going to check our answers, especially when we get negative answers. You got to check and make sure. Negative 2 plus 3 comes out to be 1. 2 minus negative 2 comes out to be 4. So both of these answers should work whenever I plug them in. Okay, last one. There's multiplication going in here because addition. So we do log 3 of x times x minus 6 is equal to 3. So when we have one log involved, we're going to go 3 to the 3 power is equal to x times x minus 6. 3 to the 3rd power is 27. X times x is x squared and minus 6x. I'm going to move the 27 over. Okay. And then factors of 27 that give you negative 6 is going to be x minus 9, x plus 3. So we get x is equal to 9 and x is equal to a negative 3. Now, we got to make sure our argument works. The 9 will work. 9 minus 6 is 3. But the negative 3 will not work because if you plug in a negative here, you can't have a negative argument. Okay? So this has been solving equations that deal with logs. Make sure you use your properties of logs. Remember, when you add logs, you combine by multiplying. When you subtract logs, you combine by division. Okay? If there's logs on both sides, you set the arguments equal to each other. If there's only one log involved, you're going to convert it to exponential notation, like we've been doing throughout this whole entire set of notes. Okay, so if you have any questions, feel free to reach out. Thanks, and have a good night.